Okay, so today we're going over net change again, but the net change problems are really what we're going over and do now. So if you're working on those problems and you found some difficulty trying to work it out, please let me know so I can go over it with you step by step. This problem does deal with a lot of various different things. Some things from your earlier math classes in school, some things from even maybe most recently pre-calculus, and some things obviously from calculus like integration, but it doesn't ask for the net change for this problem. So I just wanted to see if there were any other types of problems that you can do, and I can still answer questions about net change during this lesson, okay? And don't forget to do the practice. It's also another question that I found for you guys. So here we go. So population density measures the number of people per square mile inhabiting a given living area. So if you didn't know that, you could write that down. Watertown's population density, okay, so this place is called Watertown. I didn't make up this problem, okay. It says that its population density, which decreases as you move away from the city center, that's not unusual, can be approximated by the function 10,000 times the quantity 2 minus r. So this is a function, okay, of r. And r is measured in miles because it says at a distance of r miles from the city center. Okay, part A. Okay, if the population density approaches 0 at the edge of the city, what is the city's radius? Okay, so here we go. If you need a moment to write this down, pause the video, make sure that you get it down. You don't need all of the details, you need the important ones, okay? So you may want to know the name of the town, and we're talking about its population density and the function itself. So A, if the population density approaches 0 at the edge of the city, what is the city's radius? Okay, well, if you remember our limit problems, talked about, well, as it gets, x approaches 0, as it gets closer to 0, what is it? And some functions we're able to just kind of plug in 0 and see what our answer is. We don't want to do that here. This isn't necessarily a limit problem, but it is something to identify that we want not x to be 0, but our y. And why, you may ask, is because we want the population density to approach 0 or be 0, okay? And we need to find out r, because that's what's saying in this problem. So the only way we can do that is if we set it equal to 0 and solve. So if we solve this, then r has to be equal to 2. And since r is measured in miles, then remember it's 2 miles. Don't write 2m because that actually means 2 meters. So write out miles, okay, or mi. Now you're probably thinking, okay, she's done, but there's a b and it continues. So let me pull up the other slide before I continue b, and this gives you a moment to maybe jot down some more notes. Okay, here we go. So in B, it says, a thin ring around the center of the city has a thickness delta R and radius R. If you straighten it out, it's just a rectangular strip. Approximately what is its area? Okay. So I'm going to try drawing this out. Please don't make fun of my drawings. Or actually, you can. I'm not going to be able to hear you. But just, bear with them and try to do something like what I'm doing in this video into your notebooks, okay? Maybe you even draw better than me. All right, B. Okay, so when I'm first drawing this out, okay, so we have this circle, and it's a thin ring around the center of the city, and it has a thickness delta R. So I'm trying to draw this ring around, and it seems pretty thick, except for maybe one side to the left there. Okay, so R is the center of this circle, and we're kind of thinking about like cutting it. If we cut this, okay, and we start unraveling the circle, or I should say the ring around the circle. I'm trying to color coordinate it so that red place the way we cut it kind of got unwrapped, okay? And remember, there is a thickness to it, okay, and that's delta R, okay? It's the change in the thickness there, and they're using R for that thickness, which makes sense because it would change the radius if we started measuring it out further. If there wasn't any, it would just be R, and if we measure it out, it would be plus delta R, whatever like that change is. So that's its measurement here. And if you start to take something around a circle and stretch it out, okay, remember we went around the circle? That's this piece here. So it's actually the circumference that is the bottom part of our rectangle. Okay? So let's write this out. We know circumference is 2 pi r. So this is what I was saying before about previous classes, okay? This is probably many, many years ago. And the area of our rectangle is length times width. So when we have to plug in the information, okay, into here, area is going to be circumference, which is 2 pi r, okay, times the width, which is the change in r. So it should look something like this when you write out its area. Don't leave it as L or don't leave it as W. Don't leave it as C. Write it in terms of what we're using in the problem. So since we're using R for its radius, we should use this expression instead. And W is delta R. So hopefully you understand that, so we can move on to part C. Let me know if you have any questions. So part C asks to explain why the population of the ring in B is approximately 10,000 times the quantity 2 minus R times the quantity 2 pi r times delta R. Okay, so you should be able to find out, hey, that's our answer from before. So the reasoning behind this expression is because the population is equal to the population density times the area. Okay, so that's all we have to write out is the words. The population is equal to, and I'm going to use an equal sign instead of writing it out. I'm having a hard enough time writing is. I'm abbreviating. Times the area. Okay, and that's it. So D. D is the last part of our whole question, and of course, I did mention before it did deal with integration, so this is our integration part. D, estimate the total population of Watertown by setting up and evaluating a definite integral. Okay, so when we need the total population, all right, we need to integrate our formula from here. They actually gave us our expression we're going to integrate. Now, this takes care of, oh, I missed something. Hold on. I need more space, actually. That's my whole issue. Pi r, and then I'm not going to write delta r. Delta r is the change in r, and so is when we write dr. Okay, I've mentioned it very briefly once or twice when we started to look at Riemann sums and then went into integration. So this is why we would integrate this expression. Okay, it takes care of that change. Now we're going to do it from 0 to 2. Okay, so the reason why we're going from 0 to 2, if you remember part A, and I know I erased it a while ago, we found that r is equal to 2, okay, when we found what our city's radius is if the population density approached 0, okay, and we want to start out with an initial value of 0 for r. So that's where the 0 and 2 are coming from, okay, it's pretty much from initial value and from our understanding of part A. Okay, so now in this particular problem, you can do this by hand because you really just have a constant multiplied by 2 and it's a polynomial function. But I plug this into the calculator, so make note of that. Okay, and I got approximately 83,775.804. Okay, so now in a previous lesson we talked about you can leave the decimal places for the AP exam, even if we're talking about population of people. Even if it was a population of bunny rabbits, just leave the decimal places, but make sure that it is to 3 decimal places. All right, so let me know if you have any questions. Good luck.